Let's take a look at section 9.3 on the geometry of triangles, congruence, similarity, and the Pythagorean theorem. Okay, if you remember from high school geometry, one of the biggest things that you did was proofs dealing with congruence, which included angle, side, side, and side, angle, side. We're not actually going to do any of those, so I'm moving on to the similar problems. These are where the triangles have the same basic shape, but the measures of the sides are different. Actually, the measures of the sides are proportional. Turns out the three angle measures, though, are identical. So we'll begin with number 14. And what they ask us to do is identify the corresponding parts of the two triangles. And so I'm going to start with the angles. If I look at C is a right angle, it corresponds to R. A corresponds to P. And B corresponds to Q. Okay, now our sides, AC corresponds to PR. AB corresponds to PQ, and BC corresponds to QR. And that's all we have to do. These are angle. All right, let's move down to number 18. It says find all unknown measures in each pair of similar triangle. Okay, so as we look at number 18, we have angle C is 90 degrees, which corresponds to angle P. So angle P would be 90 degrees. So the measure of angle A is given. Measure of angle A corresponds to Q, and that's 42 degrees. And angle B corresponds to angle R. So those two are going to have the same measure, and so we would need, I think it's 48. 48 plus 42 would give us 90. Okay, 22 is much the same thing. This time we have angle Z measures 38 degrees, so that means angle P is 38 degrees. Measure of angle N and Y is given. So we need, let's see, 90 minus 38 would be 52. So the measure of angle X equals the measure of angle M, which is the 52 degrees. What I did was I took 90 minus 38. Get the 52. Alright, our next group, we're looking for the lengths of the sides. What you want to do is set up a proportion, and I usually do large over small or small over large, but I write it down To remind myself, I want to put the measure from the large triangle over the measure in the small triangles for the corresponding sides. So the bases are 75 and 25. I need that because I have to have one set that will give me the correct proportion. And what you'll notice about that is that's actually 3/1. So large to small, 3:1. That means B to 20. So we do the cross products, B equals 60. All right, large to small. And this time we don't know A, so that's A to 10. So A is 30. So those are the two we're looking for. Okay, 26 is much the same. Again, we have the bases. Let's do large to small again. So this is 9 to 3, which also happens to be 3:1. So 3:1 equals 6 to A. So we get 3A equals 6. That means A is 2. And I think we were only missing the one side there. Yeah. All right, in number 30, we have two similar triangles. This time they happen to be right triangles. And we can use the same idea, large to small. Well, let's see, what do we know? We know the bases for both. The base of the large triangle is 160 plus 40, so that's 200 over 40, which is going to be 5:1. Okay, so alright, so for the large triangle we have a 60, and the small triangle we have a y. So 5y equals 60. And dividing by 5, we get y equals 12. And I think that's all they were asking for, was just y. Okay, let's do a word problem. It says a forest fire lookout tower casts a shadow 180 feet long. Okay, so here's our tower. Okay, so it's casting, let me get those. Okay, here's our lookout tower. It's casting a shadow 180 feet long. At the same time, the shadow of a 9-foot truck, okay, here's our truck, and that's 9 feet. Casts a shadow that's 15 feet long. Okay, so we're to find the height of the tower. So what we have is we have two similar, I'm not very good at drawing these straight the way I want to. Okay, what we have is two similar triangles. And so again, we're gonna, let's do large over small since we've been doing that. See, can we reduce that? I think 15 will go into 180. 12 times. Don't trust myself. Okay. 15 into 15 goes once. So again, this is large to small. Alright, so that means we have the height of the tower to 9 is equal to our ratio large to small is 12/1. So we get H equals 12 times 9, 108. Okay, and one last one here. Let's look at number 42. Two more. 42 first. We have a right triangle, and we're using the Pythagorean theorem that says a squared plus b squared equals c squared. We have a right triangle where the two shorter legs are a and b, and the hypotenuse is c. So in number 42, we have 7 squared plus b squared equals 25 squared. So that's 49 plus b squared equals 625. Right. Now we subtract 49. We get b squared, 576. And we take the square root of 576. We get b is 24. Okay, and now the last one. Let's do 46. This is basically the same type of problem, only they don't give us the picture. But a squared plus b squared equals c squared. So 28 squared is 784 plus b squared equals 10,000. We want to subtract 784 from both sides. We get 9,214. Can we take the square root of that? Let's see, square root of 9,214. Okay, it's not an, let's see, final length of the unknown sides. Okay, so it looks like they want us to round that to the nearest whole number. So 90, I'm getting 95.989, so that would be approximately 96. Okay, so that should give you enough information to go ahead and do the online homework for section 9.3.